Hey everyone, this is Belinda Carr. Welcome back to the Boost AEC podcast, where we dive into the world of construction and explore the stories of people and companies who are shaping the future of our industry. Today, I'm speaking with Benjamin Cook, CEO of Zirconia Inc. Thanks for joining us, Benjamin.
Hi, Belinda. It's great to be here. Thank you.
We have spoken a couple of times in the past, and I find the products that your company is making is really fascinating and is really solving a genuine problem in this world. Zirconia, your company, is an advanced materials technology company, and you make ceramic coatings for concrete and steel to make them immune to corrosion. Is that a pretty good overview of what y'all do?
It is. It is. We make an inorganic ceramic coating, which makes us a little different. You know, the old plastics, epoxies, and polyurethanes, people are kind of familiar with those from the 1950s. We make something that's more modern and high tech. We make an inorganic coating that's basically ceramic particles in water, and those ceramic particles are very small in the nano range. And because they're small, they have certain really special properties. For instance, that they can fuse and make glass at room temperature without it having a kiln. And that means you can put a skin of ceramic over something like hydrating concrete, right? Like your pool deck or your garage driveway, right? You can put this layer of what we call a ceramic surface treatment. Our material, by the way, is an analog of granite. It's basically artificial stone or man-made stone. Some people use the term Roman cement, but it is very much a skin of granite. And when you paint it on just like standard paint, it's very easy to use. And the next day you come back and the concrete is repaired and protected from corrosion, basically for a very, very long time.
That's pretty amazing. But before we dive into some more details of your product and look at some examples, let's talk a little bit about your company. Where are you located?
Yeah, we're located in Tukwila, Washington, which is just below Seattle. So we're here in the Pacific Northwest. Where it's pretty rainy and foggy all the time. It's a good, challenging place for concrete to be.
Concrete corrosion is something that we all see every day, whether we really recognize it or not. We see cracks in our foundations, around pools, like you mentioned earlier, and our driveways, and we just accept it. But when it's a home, that we only think on the short term, but there are other infrastructure projects like roads and dams and spillways that are meant to last a much longer period of time. That's when corrosion is a much, much greater problem and a more expensive problem too. So your product is not just used on the small residential scale, but it can also be used on much larger projects.
Yes, if you want bridges and dams to last for hundreds of years instead of tens of years. And as it turns out, we all have this belief in concrete being strong, durable, kind of lasts forever, continues to cure forever and ever, right? These are sort of old stories, but the truth is the surface of concrete will corrode away in 10 or 20 years, depending on how much rain and how much carbonation is hitting the surface. So, things don't last all that long, and the bigger they are, a bridge, for instance, in Florida where you have salty air, it might only last 20 years, right?
That's true.
With our technology, it can last for 200 years, easily.
Why hasn't your technology been used so far? Are there competitors out there that are doing something similar that are being used?
I wish there were competitors, Belinda, because
Y'all
sometimes
wouldn't have to be the guinea
first one
pigs.
is right, because when you're the first, right, you have to tell a story and you have to educate the market. And, we're working through the different, departments of transportation or whatever state agencies that approve materials. We're working in different, we're actually working in the UK and in Saudi Arabia as well, fixing their infrastructure from salt damage. But it just takes a while when you have something new, and it is quite revolutionary. The more, I guess, revolutionary it is, the harder it is to explain.
To change people's minds.
Almost,
That's true.
right? You're putting a lot of basically a liquid granite coating that's going to make their infrastructure virtually immortal. Everybody likes the idea, but they don't necessarily understand the idea. So it's a lot of you do trials, you let people observe, and then once they get the hang of it, right, then that's when they're moving forward. We're moving forward with some dam engineers, for example.
Yes.
There are people who want to do pools. One of the nice features of this technology near a pool is if it gets wet, it actually gets more non-slip, which is the opposite of organic coatings. So
Oh,
just
wow.
really nice traits. I think one thing you and I have discussed is, concrete cracks. It cracks from the time it's new. Like even when you put it down, right, there's going to be a stress crack or an early age shrinkage crack. And this technology pours right into the crack, acts as an inorganic glue and seals and basically eliminates the crack. Everything looks like it was new. It's a great feature of this technology.
But why is it so prone to cracks? Because a lot of us see when we look at Roman architecture, and you talked about this earlier, you heard about
Yeah.
Roman cement. Those viaducts have been standing for thousands of years and are in pretty incredible condition. What has happened in the materials that we use nowadays that makes them so vulnerable to breakage?
Yeah. So Roman cements have a different chemistry. So Roman cements are basically, you can call them forms of granite, really, or man-made stone as well. They have a polymeric structure, and we don't need to talk too much about chemistry, but basically what it means is you have elements in that cement that are chemically bonded to each other. In hydrated cement, or what we call concrete, there are no chemical bonds. Nothing is actually attached to anything, which is pretty shocking if you think about the world as being held together by this gel. It's really good at holding water. So it's more appropriate, really, to think of concrete as something more like Jello than
That's disturbing.
in something
Yeah.
that's more like stone, right? So this is a piece of granite, right? And I think if you would agree with me, if I set this outside, it's going to last for hundreds of years, far, far longer than I will, right? But if I set a piece of, concrete outside, it'll start falling apart because it starts having chemical reactions, or if it's exposed to salt, it'll simply disintegrate. And that's also because there are no chemical bonds holding it together. Now, water has a special property, which is pretty amazing. We take water for granted, but sorry about that. For granted, right? For granted.
Pun intended.
Um, so water cannot be compressed, and that's a very special, very specific property. When concrete hydrates, it takes water into itself, right, and forms this hydrated gel, and that gel is pretty durable. Like it's good enough to hold rocks and sand, which makes concrete. And it can hold mass, it can hold weight because water can't be compressed. So that means concrete can hold trucks on a freeway, it can hold up bridges, it can hold up 100-story towers, in downtown New York. The only thing it can't do is protect itself from any type of chemical erosion. So if you have a flat surface that's outside and it's going to capture rainwater and carbonic acid, then it's going to suffer pretty quickly, 10 or 20 years, and the surface is gone, and you might already be down to rebar in some cases. If you're in an industrial zone, there are worse things happening because they're exposed to stronger chemicals. But
Yeah.
even near your pool, people have seen it near their pool where you have chlorine, or you might have some freeze-thaw cycles, weathering, and all of a sudden the concrete doesn't look that great after 10 or 20 years.
So is there
And that
some
just,
big conspiracy in the cement and concrete world that pushed the entire human population to move towards this cheap, not so durable material as opposed to what we used to use thousands of years ago?
yeah, concrete is inexpensive and it's really easy to use and form and shape, right? So
It's
that,
much more
that
forgiving than Roman cement.
right, Roman cement is not as easy to make, and it's more expensive.
So the best solution in today's world might be some sort of hybrid approach, which is what your company is proposing, where we still use cement and concrete, which everyone understands and everyone works with,
Right.
but then use a more durable coating on top of it to protect the cement, protect steel, which eventually makes our infrastructure and our cement projects last much longer.
Yeah, that's exactly right. I mean, concrete is just very easy to use. It's very inexpensive, and it's cheaper to manufacture as well. And you can see here, like I have this brick, right? This brick has been through a 100-year weathering test with ultraviolet light, constant applications of salt. We're actually trying to weather it, and the geopolymer surface shows no damage at all. Now, that's because Roman cements, if you expose them to salt, heat, and humidity, they just get stronger over time. So it's really kind of the opposite of concrete. Now you can see, like if I turn it sideways, you can see all the algae that's growing on this particular brick has been sitting outside for several years. We just kind of observe things over time
And
at
that's
the
a
lab.
concrete brick that is coated with your
It's a concrete
ceramic
brick
coating.
that's coated with a geopolymer coating. We call it ceramic guard. That's the name of the product. But you're absolutely right. It'd be that if you can corrosion is a phenomenon that happens from the outside in. And so concrete by its nature is generally speaking only vulnerable at the surface in most cases. So if you can stop the carbonation or the salt damage from the skin inward, then basically you can make the whole asset virtually immortal. And that's really what we're trying to educate people on. Of course, there are certain things where you can manufacture things made out of Roman cement. They're making, water pipes and sewer pipes underground now with Roman cements. They're going to last for hundreds of years, and we're all better off for it. But for this technology as a coating, the wonderful thing is you could take something with a lifespan of 1,000 years, and you could apply it to your driveway or your walkway or your pool deck or your bridge or your dam or something big, and you could transfer the lifespan to that asset, something that was not going to live very long and it wasn't going to look very good as it ages, right? So one of the nice things about our type of coating, Roman cement or skin of granite, if you will, and that is it's completely oxidative to biological life. So here in Seattle, where we get a lot of algae growth in concrete, you can see everything's kind of turning black in the winter. And it just doesn't do it at all. It's completely it's self-cleaning to a large degree, especially if there's any sunlight around. It's has a photocatalytic surface, so it's basically self-cleaning, which is really, really nice, right? If you go out to your pool deck and basically,
Don't need to
have a
power wash
self-cleaning
it. Yeah.
structure, that it's nice for different reasons. It's nice on a pool deck, maybe because whatever is coming off human bodies basically dies on the thing, and then it's nice when we do floor systems for big food production facilities, food manufacturing facilities, and they become self-sterilizing for the life of the building, which is really wonderful because that's our food supply, right?
That's
So you
true.
want to
Yeah.
protect it.
Is there a certain point in the life of the concrete where it's just too far gone? There's just too much eroded, the rebar is exposed, and using your coating just makes no sense. It has to be, unfortunately, torn down and crushed up, sent to landfills, or used as aggregate.
Yeah, I think there is. I mean, it's always nice if people can recycle the concrete into aggregate, as you say.
If that does happen,
But
right?
this technology, the Roman cement, we use a coating. We also have some Roman cement repair material, and you can see what that looks like here. It's extremely dense. Again, it's a dense form of liquid granite is what it is. But you can
Is
repair
that pure?
concrete.
Is that pure Roman cement, or the material that
It
you've made?
is.
That's not a coating or anything.
Yeah, this is not
What
a
would
coating.
that be used for?
If you wanted to fill up cracks that are bigger than about a quarter of an inch, so the ceramic guard, when you pour it into something, it will fill up cracks up to about a quarter of an inch. If you want to go up bigger than that, then you need something like this, which is a self-leveling Roman cement. Basically, it's another word for Roman cement is a geopolymer. They're aluminosilicate polymers. In any case, this pours into a crack like cake batter. It's 4,000 psi at 24 hours, 12,000 psi at 28 days. It's really strong. It's very dense. It's basically waterproof. And it does some other things. I mean, it's really nice when you have rebar. So here's an example, right? Of you have the Roman cement down below. You have the ceramic coating of ours, the ceramic guard on the steel. This is basically waterproof, timeless. The nature of
So that
these
is
Romans.
preventing the steel from rusting, and it's preventing the concrete from eroding. It's doing both.
Correct, correct.
So
Because
that
when you're
particular
patching something, right, you want to these Roman cements in the form of a coating or in the form of a mortar, they go in and they glue the hydrated concrete. They group what you think of as concrete, they glue it all together. So they don't just stick to it. Plastics stick and then they stop sticking, right?
and
So they peel
epoxies
off.
too,
Right.
all
Because
those
adhesion
temporary
is
fillers we use.
right. Plastics use adhesion is a temporary chemical state, right? It's just going to get a little bit of heat, humidity, and then it's going to stop being sticky anymore. But these materials are looking to chemically bond with whatever they can find. They'll bond with all the calcium in standard concrete, and then they basically form, basically it's a layer of granite. It's far more durable than the concrete itself. And if you're going to go and fix like bridges and dams or could be just fixing your driveway, this is the best way you could do it because it's a permanent fix.
How does it compare in cost to all the other temporary fixes that are out there right now?
Generally speaking, our coating is $2 to $2.50 a square foot. So you can look at other types of coatings. There really isn't anything for outdoors that you can compare it to because plastics cannot survive outdoors.
Yeah. I've
If you
seen
go
garage
indoor,
door epoxy pours, but I haven't seen them being used on
right,
in
so long as
driveways
they're
and
not
stuff.
exposed to humidity or the sun for very long, they can survive kind of sort of for a while, 4 or 5, 6 years, right? In these, you're looking at 4, 5, 600 years.
Wow.
So it's a little different.
What's some
But
of the biggest
outdoors,
projects that you have worked on? Speaking of outdoor projects.
oh, say again?
Speaking of outdoor projects, what are some of the biggest and most exciting projects that your company has worked on?
Sure. I think when we started way back in the 2000s, we were working with Department of Transportation grants. And so several $1 million of grant money went into developing coatings for steel and concrete. And we have projects in the greater New Jersey area. There's one wall that we colorized the geopolymer red. That's been exposed to sun and road salts and freeze thaw cycles and still looks brand new from I think 2007. And then we had another area of a bridge, a section that they gave us, and we coated it. And the interesting thing, if you look at it from some of the pictures I sent you, Belinda, and that is you'll see that nothing, years after you coated this thing, it looks new. And also there's nothing growing on it because in New Jersey, you have warm, humid summers and you get a lot of algae growing on the concrete. And unfortunately, the algae feeds on the concrete and on the calcium in the concrete. So it's actually eating the concrete away, which is another reason that concrete corrodes in addition to salt and carbonation. And you can see our tech looking perfect and clean, and the rest of the bridge looking brown with algae, right? This
Yeah.
is so there's multiple benefits of the ceramic guard coating,
Yeah.
and our big push really in the marketplace, and also just helping people educate themselves on the construction industry. So we want to help stop concrete corrosion. Most corrosion is from simple carbonation from atmospheric, CO2 converting to carbonic acid. Um, and then, but salt damage. Half the population in the United States lives near the ocean, and for instance, people in Florida, as we know, have had some unfortunate events around salt corrosion. Our material completely stops salt corrosion from happening. In fact, geopolymer coatings like ours really enjoy the heat, sun, and salt, help it become stronger and denser over time. So there's really
And
there's no
why is
downside.
that? What happens within the material itself that makes it stronger when exposed to those elements?
Yeah. So um, the the easy way to say that, I guess, is that this type of material has a certain catalytic nature when it reacts with water, and it basically pulls the water molecule apart, takes the oxygen out, and uses it as a polymer, part of the polymer. It
Okay.
basically converts it to ceramic. So, and it releases hydrogen gas at the surface. You don't really notice it, but what you'll notice over some time, we have.
So is it a living
We have
material in that sense? Because there are chemical changes happening at the surface throughout the life of the material.
Yeah, people use that term self-healing and so on now with concrete and so on. So there's a little bit of that going on for sure. I think it's interesting. You can go up, years later and basically sharpen your knife on this coating. It is ceramic, right? It's 10 to 100 times stronger than steel, depending on what we put in it. Sometimes we use a blend with some very hard ceramics like silica carbide, in which case it has a surface that's 100 times stronger than steel. And that's helpful when you have areas where, like bridges, where cars or something might impact the concrete and you're trying to create a durable surface. Um,
So
but
are
it's
there
just it's a
continuous
wonderful feature of this technology that as it ages, it actually gets better.
yeah. Are there continuous improvements going on at your company to develop new formulas with this technology, depending on the area or the region of the country you're working in? Because you talked about developing a formula that is stronger than your standard formula, or is it like how does that work?
Yeah, well, again, we get to play in our sandbox, which has a series of nanoparticles. We're concerned with climate and basically adapting to climate change. So some of the things we're doing have to do with things like abrasion or wear, in which case we could put harder ceramics in the mix. And some of the things have to do with like reflecting heat, right? Reflecting infrared, reflecting sunlight. So if we want to make something, we have a technology here that's a ceramic surface treatment. This reflects 99. It's considered 99% solar reflective index, which is a measurement that people use for roof systems, right? So 99%, pretty good. Um, it reflects most of the heat off of a roof or a building. So in really hot parts of the world, if you're living in India, Saudi Arabia, Bakersfield, California, where you have a lot of desert and it's 110, 120 degrees in August, you can have something like this on your roof or on the walls of the building, especially, of course, south facing. And most of the sun's energy is not going to make it into your building, which is pretty great. And one thing that means is you're not going to have to pay your air conditioning bill because you don't need the air conditioner half as much,
Yeah.
right? And that's great for, areas of the world like where you live down in Texas, right? Where, everybody has their AC on full blast during the summer,
Mm-hmm.
right? But you might only use half the energy if you have this coating.
Yeah. I spoke to a company a while back and I mentioned in one of my videos, it was called Sunshield. They sent me a product. It was this white ceramic paint that you can use on your roofs. Is that similar to what y'all make?
Yeah, it's a similar it's a similar concept, right? They're all ceramic elements,
Okay.
right? Ours is nice because it forms a polymer and it basically forms a layer of stone over whatever is there. And our material is,
As
again,
opposed to it just being paint.
as
It's a harder
opposed to it
material.
being paint. So some people put ceramics inside plastic paint, like a latex,
Yeah, I think that's what this
oxy
was.
or something. And the problem with that is that the nature of these types of ceramic particles, when you get in, most people are using some form of titanium dioxide, which makes all paint white, right? Could be
Yeah.
any paint. But the problem is there's a chemical reaction with the sun that tears the paint apart. So you can put it on there, but it's going to self-destruct. So that might be good though. Maybe it's good enough for 20 years, right?
Yeah.
Construction industry, good enough is good enough in a lot of cases. But in our case, our technology is completely inorganic, right? So there's nothing to break down, and it's just basically it's gonna outlive all of us.
Is there a particular project that comes to mind that was really challenging for your company where you had to develop a new type of a ceramic coating that y'all hadn't developed before and really pushed you out to your limits?
Yeah, I think when we were first starting out, we began playing with engineering around industrial facilities. And we have our ceramic guard, which stabilizes the concrete. And then we wanted to create a hybrid of an organic, inorganic top coat layer that could deal with the extreme acids, food acids, or heat, or other types of industrial chemicals, maybe a sulfuric acid or some such. And we created a series of different coatings where we could put a organic layer over the inorganic surface and chemically bond the entire thing into the concrete itself. So
And that was
epoxies
something
of
that
the
y'all
type
hadn't done before.
it had not been done before. So when you're looking at technology like this,
Can you raise it up, please? Yeah. Okay, perfect. Yeah.
so when you're looking, this is called Composite Coat XD. This particular sample has been sat in food acid, and there's an abrasive scrubber pad that's been over this 100,000 times, and there's no damage. And that's because it's molecularly bonded into the concrete, and it has a hybrid organic, inorganic top coat that's chemically bonded into the ceramic guard itself, right? So if
And
you
the
can look
back
at,
side of that sample shows how the uncoated cement reacted to all the acids.
right, so here's a piece, again, sat in acid and scrubbed. This is what modern technology looks like, right? This is 10,000 scrubs, because it doesn't survive more than that. This is the most expensive epoxy you can buy that is highly chemically resilient. This is a Novolac epoxy, $15 to $20 a square foot. Very expensive. Ours is about $5. So it's both more expensive and its lifespan is not much. So for us, we've gone into big factories. We've done projects at, Amazon, San Jose State University.
At their data centers, Amazon data centers?
The data centers, yeah, it's interesting. The data centers now are not built, I mean, they're built like large air conditioners. And so they have louvered walls where the ice and snow and wind can come in because they have all this heat generated from the servers themselves, right?
Yes.
So they use a lot of electricity, and that produces a lot of heat and resistance, and that heat has to go somewhere. So the reason they liked our technology, again, you can see it on some of these samples, like the ceramic guard sample here. So this goes on, it mixes with water. There's no VOCs. There's no organic chemistry that gets up into the air that you're breathing. And Amazon had a building full of very expensive equipment and very expensive engineers. and it was already in operation because they were behind schedule. And they just brought our material in to preserve the concrete. Now, this is an interesting sample because if you could get up close to it and see it, there's a crack right down the center, and the ceramic guard has just gone in, sealed the crack, sealed the surface, and the whole thing is completely stabilized. So there's when the ceramic guard goes on the surface, there's no porosity left, and the surface is completely chemically stabilized, so nothing can really harm it. Or it's very, very difficult to damage.
That's pretty fascinating.
Material,
Yeah.
this material is also it's immune to heat, flame. It's fireproof, and we say zero flame, zero smoke. But you can put a torch on this material, and it can heat up to 1,000. It can be glowing red hot like a coal,
And still
and
wouldn't
nothing.
catch on fire, wouldn't disintegrate. Yeah.
No. But the interesting thing is concrete starts to disintegrate at about 400 degrees.
So this is protecting the underlayer.
So this is protecting the concrete. And if we hear stories in the news, there's a forest fire or there's some fire near a freeway and the whole thing starts crumbling. Well, it can't rely on concrete to be, concrete holds water. And when the water leaves, everything just turns back to particles, right?
That's true.
Probably not the best thing to happen to your freeway.
So I would think that our AC industry would have embraced your product and been really excited about it and used it on several projects. Is that the kind of reception you've experienced?
So we are looking to expand into the anti-corrosion market around the United States, and we're getting a really positive response to our offerings. We've just kind of started this big push. We were doing industrial coating systems for some time because of some of the advantages that we've discussed. And now that we're working toward major infrastructure, we've been, I'm not sure how to say this. We've been adopted by several engineering firms. Some of the engineering firms work on dams, so they're excited to have something to repair the spillways.
And you've said earlier that you've been working on some international projects too. So it's not just within the States. People outside the States too have been realizing the value of your ceramic product.
That's right. In the UK, they're using our technology to repair old wastewater infrastructure. That's it's outside and it's carbonated and it kind of just from age and wear. Our material, again, goes on, chemically bonds. It's an inorganic glue, glues everything back together and basically restores its function. In Saudi Arabia, they use seawater for cooling, and they use seawater for desalination for fresh water because they don't have rain. So they can use our material to protect their desalination plants or protect these large cooling towers from disintegrating, or just their homes and apartment buildings. They have salty sandstorms. A lot of it's near the ocean where you have salty, humid air. They have a lot of salt corrosion, and our material just completely stops salt corrosion.
That's fascinating.
We're reaching out to there's a National Association of Corrosion Engineers. It's called AMPP. I don't know if I start saying acronyms if people get lost on acronyms. But the National Association of Corrosion Engineers has adopted our technology. Really is it helping us sort of spread the word because we're a newer startup, and so they are sharing our information. They recently published an article in Materials Performance magazine and sent that out to the National Association of Corrosion Engineers around the world. People have never had a technology that stopped concrete corrosion before, and so it's quite revolutionary because we've been building up. We have this backlog of dams and bridges which are all suffering from salt corrosion, or
waiting for a solution.
But the bridge is shut down for repair and you have to go around, and people are stuck in traffic as a result. There's all sorts of problems when your core infrastructure starts breaking down, and we can solve those issues. So we can go on new concrete, or we can preserve existing concrete that's been damaged, at least partially damaged if it's not fully lost its structural integrity. And that's something that people have never had before. So there are a lot of people who are excited about it. A lot of engineers, mostly. We can kind of get in there and solve their problems for them.
That's fascinating, Benjamin. Thanks for sharing all that information about your company and how the product works. And I hope I get my hands on a couple of samples in the future to get some close-up shots and really understand, play around with it, because that would be really fascinating. Your role in the AEC industry is a little atypical. It's not. I've talked to a lot of people who are just typical engineers, typical architects and builders. You're coming in from more of a material sciences
Right.
lens. So what advice would you have for a young professional who's not taking the typical path and who's looking to maybe go down some a different path like you have?
For in material science, we study material science, materials engineering, but also I think having some entrepreneurial skill sets, understanding how to focus a business, how to develop, deal with financials, and basically keep the company focused around the concept of marketing and educating your clients. These types of things. You can have the greatest project, but if you can't explain it, then it kind of gets lost in the weeds, right? 'Cause there's a lot of products out there. What is the actual difference? How do they actually function? Why are they special? In our case, we have kind of an interesting story, just because the people kind of, at least the architect community, people kind of understand Roman cements, maybe not in detail, but it's a nice backstory. You can kind of build on that backstory, talk about, paintable granite and all that.
Yeah. Well, that's excellent advice for any up and comer because, like you said, you can have the best product in the world that solves a genuine multi-trillion-dollar issue that countries around the world are facing. But if you're not able to maintain a financially viable business, then it could just get lost. And that would be such a shame because a product like yours is really needed. So I think that's excellent advice. And I'm, again, looking forward to hearing about your company in the news and seeing your company grow.
Thanks, Belinda.
You did an excellent job explaining a very complex problem to us. And I want to applaud you on that.
Thank you. Thank you.